Okay, so today I'm going to talk about quadratic equations and quadratic functions. Um, so something I'm sure you've probably learned before, but it's pretty important, so I thought I'd talk about it a little bit, is the Pythagorean theorem, which is a squared plus b squared equals c squared, and it's used for any right triangles. All right, so C is the hypotenuse, that's the longest side of the triangle, and then A and B are the other sides, which are called the legs. And so it just applies for right triangles, which is any triangle where there's a right angle, which is a 90-degree angle. All right, so if we have B is 5, C is 10, and we want to figure out A, so I like to start with just drawing my triangle. And A and B are pretty much interchangeable, so it doesn't matter like which one is A or B. We know this one is going to be C, which is 10. And then this can be A, which, or okay, this will be A, which we don't know. And this is B, which is 5. So A squared plus 5 squared equals 10 squared. And then we just try to solve for A. That would be A squared plus 25 equals 100. And then subtract 25 from both sides. So A squared equals 75. And then in order to solve for A, we would take the square root of both sides. And then we would want to break down that square root. And I went over this last week, so I would break that down with a factor tree. So the smallest prime number I could go into that would be 3. 3 goes into 75 25 times, and then that's 5 and 5. And then since I have a pair of 5s, that means I'm going to have a 5 on the outside of the radical, and then that 3 is going to be left on the inside of the radical. So A equals 5 times the square root of 3.
Okay. Okay. I get it.
Good deal. All right. So number 2, same kind of thing. So C is 15, and then A is equal to 2B, and we don't know B. So in place of A squared, I'm just going to put 2B squared, and I need to put parentheses around that. So then that'll be plus B squared equals 15 squared. So 2B squared, once I get rid of the parentheses, it's going to end up as 4B squared plus B squared equals. And then I believe that's going to be 225. Just check my calculator real quick. 15 squared, 225. So 4B squared plus B squared, combine those like terms, so there's an invisible 1 there. That's 5B squared equals 225. And then divide both sides by 5. So 225 divided by 5 is 45. That would give me B squared equals 45. And then I'm going to break that down. That would be 3 and 15, which is then 3 and 5. And I have a pair of 3's this time, so B is going to equal 3 times the square root of 5. Then I also need to say what A is equal to. I know that A is equal to 2B, so A is equal to 2 times 3 times the square root of 5. So that means A is equal to 6 times the square root of 5.
Okay. So whichever number match that's what goes outside the square root. So
Correct.
33, that's what goes outside.
Right.
Okay.
Mm-hmm. Mm-hmm. You got it. All right.
Okay.
And then here's another application for quadratic functions. This one it goes along with physics. This one's used a lot. So basically, if you have an object that is launched at 64 meters per second from the ground, all right, so anytime you have an object that is launched, you know, it's shot out of a cannon or you throw it or etc. And if the shape of it follows the shape of a parabola, so a quadratic function is used to model that. So they want to know, all right, so it gives the equation for the object's height s at time t seconds after launch. S of t equals negative 16t squared plus 64t, where s is in meters. And when will the object reach a height of 128 meters? So you would plug that 128 in for s of t. So it would be 128 equals negative 16t squared plus 64t. So we could divide everything by negative 16 just to make it a little simpler. All right, so 128 divided by negative 16 is negative 8. And then that's just going to cancel out and be t squared. And 64 divided by negative 16 is negative 4. So plus, or actually you could just say minus 4t. Okay. And then I would put everything on one side. So like add 8 to both sides. So basically 0 equals t squared minus 4t plus 8. So it seems like we would be able to factor that. So we'll give that a try. All right, so two numbers that multiply to a positive and add up to a negative, it would have to be two negatives. So the only numbers that can multiply to 1 and 8 are going to be 1 and 8 or 2 and 4, but neither one of those is going to add up to 4. So in that case, that means I can't factor this. So it might mean it's no solution, but it could still be a solution. So what you should do is use the quadratic formula. So let's try that. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, instead of x, we have t. So t equals negative negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 8 all over 2 times 1. So t equals 4 plus or minus the square root. So that's going to be 16 minus 32. That's going to be negative 16 all over 2. So this is going to be an imaginary answer because the square root of a negative is not a real number. So since there's no real solution, that tells me that this object will never actually reach a height of 128 meters. So the answer is never. It won't ever reach that height.
Okay. So like for the B, the A, and the C, what numbers did you use?
So it's ax squared plus bx plus c. So like in this case, a is 1, b is -4, and c is 8.
So just so how will you know which one was which? Like,
So
could
uh,
B
it's
be -8?
it's ax squared plus bx plus c. So whatever number is in front. So and it may be a little bit confusing because this is t instead of x, whereas usually it's x. But whatever number is in the front of the x squared or the t squared, that's a. And then the middle number, that's b. And then the number on the end, that's c.
Oh, okay. I get that.
All right. And then when will the object hit the ground? So if it hits the ground, that means that the height is 0. So this time we're just going to plug in 0 for the height. So it would be 0 equals -16t squared plus 64t. All right, so I want to try to solve that. So again, I could just go ahead and divide everything by -16. So that would make it 0 equals t squared minus 4t. And then I could just factor out the greatest common factor between these two, which is just going to be t. I could just factor a t out, and then that would be t minus 4. So 0 equals t times t minus 4. So set each one of those factors equal to 0 separately. So one answer would be t equals 0, and the other answer would be t minus 4 equals 0. And if you solve that, just add 4 to both sides, that gives you t equals 4. So this one is time equals 0. So that means that's like at the very beginning before the object actually gets launched into the air. And then this is where it hits the ground at 4 seconds. So the answer to this would be 4 seconds after launch. So let me draw a little sketch of kind of what this looks like. So it starts out basically, so this is the x-axis, this represents time, and then the y-axis, this represents the height of the object. So it starts here, and it just like goes up and hits the ground. So where it hits the ground, that's 4 seconds. And then we determined that it doesn't ever reach a height of 128 meters. So that tells us that this top part is below 128. So 128 would be someplace up here above the top. It would be 128. And then the next thing we're going to learn is how to calculate what the top maximum height is.
Okay.
So, all right. So there's two different forms that your quadratic function can take. There's the vertex form and the standard form. So the standard form is the one that we just talked about when we did the quadratic formula. So if your function is in that form, then you can calculate the vertex, which is that highest or lowest point of the parabola. The graph of a quadratic is called a parabola, and the highest or the lowest point on that parabola is called the vertex. So you can calculate the x coordinate of the vertex by just using negative b over 2a. So on that problem we were just looking at, if we wanted to find out what the actual height of it is, we just do negative b over 2a. So in this case, that would mean negative 64 over 2 times negative 16, because that's b and that's a. So negative b over 2a. So negative 64 over negative 32 equals a positive 2. And so that's the x coordinate, or in this case, that's the time. So it reaches the maximum height at 2 seconds, which kind of makes sense because it's halfway in between here and here. And then if we want to know what the actual maximum height is, we just plug that 2 back into the function. So s of 2 equals negative 16 times 2 squared plus 64 times 2. So that would be, we could even just plug that in the calculator. And it comes out to be 64. So 64 is that maximum height. So actually, this point right here, the highest point, is at 64 meters. Okay, so those are some applications. All right, let's see. So that was using standard form, and like so, there's also something called the vertex form, a times x minus h squared plus k. And so the good thing about having the equation in that form is it makes it really obvious where your vertex is, because your vertex is just going to be hk. So you don't even have to use a formula. And so here's an example. Did you have a question? So here's an example.
So far.
All right. Okay, so here's an example where we have vertex form. And so if you compare this to x minus h squared plus k, then we see that, so in this case, it's going to be h is 5 and k is negative 4. So the vertex is 5 comma negative 4. So pretty much when you look at it, because the negative in this formula, it's going to be like the opposite of what you have right here. That's going to be your h, and then whatever you have here, that's going to be the k, and that's where the vertex is. So I could go ahead and plot that point on the graph. Okay, so there's the vertex on the graph. Okay, let's see. So the graph of the parabola is symmetric. So it always has an axis of symmetry at wherever the x value of the vertex is. So x equals 5 would be the equation of the axis of symmetry. So basically, this is the axis of symmetry going through the middle of the parabola. All right, so in order to graph it, all we really need is just like one other point. on the graph. So let's see if we can calculate the x-intercepts. So to do that, we just set it equal to 0. So we would say x minus 5 squared minus 4 equals 0, and then try to solve for x. So add 4 to both sides. So x minus 5 squared equals 4. And then we would take the square root of both sides. So that would be x minus 5 equals plus or minus 2. And then add 5 to both sides. So x is equal to 5 plus or minus 2. So 5 plus 2 would be 7, and 5 minus 2 would be 3. So 7 and 3 are the x-intercepts of the graph. So there, that's 3, 4, 5, 6, 7. Right, and then I could draw the graph from there. All right. Okay. And all of these are going to have a domain of all real numbers, or in other words, negative infinity to infinity, because you can tell that because you have the arrows going off basically towards the left and right. So from negative infinity to infinity, or another way to write that is like this. This is another symbol for all real numbers. It's like an R with 2 sticks. And the range is the y values. So that's going to be from -4 up to infinity. So the range is from the lowest point to the highest point, which in this case would be from -4 to infinity. And this bracket is just showing that a point actually exists at -4.
Okay.
All right. And we could, I'm not necessarily gonna think we have to calculate all of these parts, but to calculate the y-intercept, you would just plug in 0 for x. So you would just do 0 minus 5 squared minus 4. So that would be 25 minus 4. So that would be 21. So your y-intercept would be 21. And I mean, I don't have room to graph it, so that's okay. All right. I guess I might as well do all these. So increasing would be like, so if you're moving along this parabola, increasing is the part where you're going up. So that's going to be from 5 to infinity. So it's basically like which section of the domain is it going up? So that's from 5 to infinity. And then the decreasing is this side. That's from negative infinity to 5. So it's just on either side of that vertex. All right.
Okay. Got it.
All right. All right, let's see. I probably won't have time to do all of them, so I'll just kind of, maybe I'll just skip every other one or something like that. Let's see. Okay. Might have time to do all of them, I don't know. Let's do, go ahead and do number 4. All right. So this one is in standard form. We have f of x equals x squared plus 6x plus 5. So in that case, to find the vertex, we would do x equals negative b over 2a. So that would be negative 6 over 2 times 1. So that would be negative 6 over 2, which equals negative 3. And then we can just plug that in. So f of negative 3, so that's negative 3 squared plus 6 times negative 3 plus 5. And I could just type that in the calculator. And that comes out to be negative 4. 4 o'clock. It's time for the motorcycle clock. All right, negative 3. So there's that vertex. And that also means that we have the axis of symmetry is at x equals negative 3. So, all right, let's see. Now in this form, it's really easy to identify the y-intercept because it's always just going to be that number on the end. Because, and you can see that too, if you go ahead and you plug in 0 for x, 0 squared plus 6 times 0 plus 5, well, that's going to be 0 plus 0 plus 5. So it's just going to be 5. So I just automatically know that if I have it in this form, that number on the end there, that's my y-intercept. But unfortunately, I didn't make my graph quite big enough to plot that, so that's okay. Let's look for the x-intercept. So 0 equals x squared plus 6x plus 5. We can just factor this one. That would be, so 2 numbers that multiply to 5 but add up to 6 would be 1 and 5. So that means that x equals negative 1 and negative 5. And that makes sense when you look at it on the graph. All right, and as always, the domain is all real numbers. And in this case, the range would be from negative 4 to infinity. And it's increasing from negative 3 to infinity. And it's decreasing from negative infinity to negative 3. Okay. Let's do this one. We've got negative 3x squared plus 24x minus 46. All right, so that's in the standard form. So to find the vertex, x equals negative b over 2a. So that would be x equals negative 24 over 2 times negative 3. So negative 24 over negative 6 equals positive 4. And then I'll plug that into the function to get the y value. So negative 3 times 4 squared plus 24 times 4 minus 46. And I'll just plug that in the calculator. And that gives me negative, wait, I think yeah, I messed up. Try that again. Negative 3 times 4 squared plus 24 times 4 minus 46. Okay, that gave me 2. All right. So 4, 2. All right. And let's see. I know that my y-intercept would be negative 46, which I obviously don't have room to put that on the graph. And let's see. Finding the x-intercepts doesn't seem like a whole lot of fun. I don't think it would be. I don't necessarily have to have the x-intercepts in order to graph it. I just have to have like 1 or 2 other points. So what I'll do is just make like an x and y table. Just pick some x values to plug in. And so usually the best x value to plug in is something that's right next to your vertex. So I'm going to go ahead and do plug in 3 for my x. Yeah, that's probably a good idea. All right, so just plug that into the function. So negative 3 times 3 squared plus 24 times 3 minus 46. And I can just plug that in the calculator. And that gave me negative 1. So there's a point I can plot. Right there. Oh, and my axis of symmetry, which is going to be x equals 4. So it looks like this. And I can actually just use the symmetry to like jump across that axis and put a point right there. Or I could plug in 5, but it would give me the same answer. So there's my graph. I still know that the domain is all real numbers. And the range in this case, so since we had a negative in the front, then therefore the parabola is pointing down in this case. So the range is going to go from negative infinity, because it's pointing down, all the way up to positive 2. And then it's, in this case, it's increasing from negative infinity until 4. And then decreasing from 4 to infinity. All right. Okay. All right, let's see. On this one, again, it's standard form, so I can do x equals negative b over 2a. So that's going to be negative 4 over 2 times 2. So that's just going to be 4 over 4, which equals 1. And then I'll just plug that in to get the y value. So 2 times 1 squared minus 4 times 1 plus 5. So that's just going to be 3. So 1, 3 is the vertex. So that means I've got an axis of symmetry at x equals 1. Okay. And I know that the y-intercept is going to be 5. And I have room to plot that this time. So even this is my vertex, and this is my y-intercept. And also I know that my leading coefficient here is positive. So it's going to be going up like this. So it's not ever going to actually touch the x-axis. So I already know from that that there are no x-intercepts on this one. And if I want to get a point, I can just hop over my axis of symmetry and put a point like that. And then I can just draw the graph from that. Okay. So graphing is really important. That's why I didn't want you guys using graphing calculators, because I want you to really learn how to do graphs. All right. So the domain is all real numbers. And then range is going to be from 3 to infinity. And it's increasing from 1 to infinity and decreasing from negative infinity to 1. Go ahead and do this one. So this one's in vertex form. So we can see that h is 2 and k is 1. So the vertex is just going to be 2, 1. Let's see, right there. And then the axis of symmetry, that'd be x equals 2. All right, let's see here. Okay. So let's go ahead and just make a table to find another point on the graph. And again, I want to pick an x value that's right next to the vertex. So I'm going to pick 1. So -3 times 1 minus 2 squared plus 1. And I can plug that in my calculator. That gives me -2. And then, let's see, so here's my axis of symmetry. I can just hop over my axis of symmetry, put another point right there. And then there's my goal. And so as always, the domain is all real numbers. And then in this case, the range is going to go from negative infinity up to 1. And it's increasing from negative infinity to 2 and decreasing from 2 to infinity. Okay, and I'll go ahead and do this one. So in this case, again, it's in vertex form. So if you compared it with x minus h squared plus k, so in this case, h would be, so it's the opposite of this number. So it's going to be -4. And then k is going to be 0. So there's the vertex. So the vertex is already on the x-axis. So I already know that that is my x-intercept. It's at -4. And then let's see, if I wanted to find out my y-intercept, I can just plug in 0 for x, so that'd be 0 plus 4 squared, which would equal 16. And I don't have room to graph that, so I'll just make a table to find some other points. Let's see, I know I have an axis of symmetry at x equals -4. So I'm going to make a table and I want to pick an x value that's right next to my vertex. So I'm going to pick -3. So -3 plus 4 squared. So -3 plus 4 is 1, and then 1 squared is just going to be 1. So right there, and then I can just hop over my axis of symmetry, have another point right there. All right. And so my domain is all real numbers. My range is from 0 to infinity. It's increasing from -4 to infinity and decreasing from -infinity to -4. All right, let's see. All right, I've got time to do one more application problem. So let's see, it says the revenue of a charter bus company depends on the number of unsold seats. If revenue in dollars R of x is given by R of x equals -x squared plus 50x plus 5,000, where x is the number of unsold seats. Find the number of unsold seats that produce the maximum revenue, and what is the maximum revenue? So anytime you have a word problem that's asking about the maximum or the minimum, you're going to be looking for the vertex. So our function is R of x equals -x squared plus 50x plus 5,000. So if I want to find the x value of the vertex, x equals -b over 2a. So that's going to be -50 over 2 times -1. That's -50 over -2, which would equal +25. So x is the number of unsold seats. So that's the number of unsold seats that would produce the maximum revenue for this company. And then we just need to plug that in to find out what is the maximum revenue. So R of 25 equals negative parentheses 25 squared plus 50 times 25 plus 5,000. And I'll just put that in my calculator. So $5,625. So that is the maximum revenue. And that happens when you have exactly 25 unsold seats. So it's important to know what your variables represent. So if they ask you what is the maximum revenue, some people will make the mistake of just finding the 25 and giving that as the answer, but that would be wrong. Any questions?
No.
Mhm. I have a little bit of time. Maybe I'll go ahead and do one more. And this one's pretty easy. This is just looking at the graph and then figuring out the equation from there. So like it shows you the vertex. You've got h is -2 and then k is 3. So it's easiest to use the vertex form. F of x equals a times x minus h squared plus k. So we would plug in -2 and then plug in 3. So f of x equals a times x minus -2 squared plus 3. So that's f of x equals a times x plus 2 squared plus 3. So that's almost the answer, except for we have to figure out what a is. So to do that, we would use this point over here, which has 0 is x when y is -1. So plug in 0, and y is the same thing as f of x. So we could plug in -1 for that. So -1 equals a times 0 plus 2 squared plus 3. We're trying to solve for a. So that would be 2 squared would be 4. So that's basically 4a. -1 equals 4a plus 3. And then subtract 3 from both sides. So -4 equals 4a. And then divide both sides by 4. So that's -1 equals a. So then just go back up here and put -1 in place of a, we're there. So your final answer would be f of x equals negative, parentheses, x minus, or x plus 2 rather, squared plus 3. So we don't really even need the 1 there. It's invisible. It just puts the negative. So that would be the equation for that graph. All right. So I think that's all I have for today.
Okay.
Thanks for joining me.
You're
Hopefully
welcome.
see you next time.
Okay. Wait, when is the next one?
Thursday.
Thursday? Okay.
Yeah, I do every Tuesday and Thursday at 3:30.
Okay.
All right. Thanks.
Have a good day.
Thanks, you too. Bye.
Thank you.